Okay, let's get started on the next lesson. Now, I should tell you something. I told the engineers, so I'll tell this group as well. Did what mobile phone company do most of you use? Three.
What?
Yeah. What mobile network do you use? That's who I use as well. But I switched because a new company launched last week, and they have a really good deal. You know them. You've seen their ads. Yeah. So it's unlimited calls.
Yeah.
Huh?
They pay you. Yeah.
No. I just sharing my bargain. Unlimited calls, text, and internet for €10.
Wow.
Yeah, I know. So that's why I thought you'd want to know about it. Because I think with 3 it's 15, 20. Yeah.
Why didn't you tell me yesterday?
Unlimited. But if you go over 80 gigabytes, they slow your speed down.
80?
80. Well, that's pretty high. Yeah.
Because I was also paying, I'm paying now €10 for like 5G. It's more than enough for me, but...
Yeah, 5 gigabytes.
Yeah.
Well, it depends if you're going to be watching lots of YouTube or whatever. I think that would chew it up the most. But anyways, I thought being students you would like a bargain. So that can't even beat Lycra Mobile, which I already thought was pretty cheap. Because I think my one is €9 a month or something. So if you want to switch, you can. But I don't know, is your €20 a top up or a contract? Oh, good. So you can go on their website. You can put in your phone number. You can pick a day when you want to switch, and then they send you out a new SIM card, and you just swap the SIM cards, and you can keep your number. So, yeah, it's pretty good. But their offer is only for the first 100,000 customers, so I don't think they've reached that number yet.
Is it possible to have 2 SIMs? Yeah.
Oh yeah, you can order a new number from them too. You don't have to switch.
Does it have a yes SIMs or?
Does it have what?
Yeah, like electronic SIMs.
What do you mean?
Yes SIMs like virtual that you don't need to put in.
No, I think it'd be like a little plastic SIM card. I don't think we have those here.
Yeah, you know, like you're like Irish guy. The kebab yesterday, I was still recovering today.
No, I don't know this.
So after it, I was like, I wasn't eating for 6 hours.
Yeah, I told you, it'd fill you up. It would be
liked
lunch and dinner.
It wasn't healthy at all, but...
I know bargains. Okay. Right, well anyways, guys, you can, if you want, you can look at them later. I thought it's going to be difficult to do better than €10 offer like that. Right, so, what we're having a look at now is log equations. So the first one here is pretty straightforward example. You just need to remember the definition of log, which says 2 power, what can you change this into? 2 power 1, yeah, equals x then. Yeah, so that's our first example there. So here x is 2. Okay, that's a straightforward example. Now, Dasha, you were asking me in the last lesson, do you need to sub your answer back in to check? So, not for the exponential equations, but for the log equations, you should. This one is pretty straightforward. You don't really need to. It's kind of obvious it works. Log 2 equals 1. But when you start dealing with log equations, it is good to make sure your answers work. Because it's possible, we'll see in a moment, that you might get an answer and it doesn't work. Or maybe you get 2 answers, only one of them work. Or maybe both, or maybe none. You know? We'll have a look at more difficult examples now. Now the next example, there's 2 ways to do it, depending on which calculator you have. So I'll show you the way that works for all calculators, and then I'll show you the way it works for the Casio calculator. So if you have 4 power x equals 9, what you could do is put log on both sides. Log 4x equals log 9. bring the x down. X log 4 equals log 9. And then divide it. So that's log 9 over log 4, which will be a decimal. What would that be? 1.58 then. You can check the answer. 4 to the power of 1.58 should roughly equal 9, roughly. Like, what is it, 8.9? 8.9? Yeah, 8.94? Yeah, okay, so it's pretty close because of the rounding. Now that method works for any calculator because everybody's calculator has the ln button on it, the natural log button. Okay? But if you have the Casio calculator, you realize that 4x equals 9 is the same question as saying 4 to what power gives 9. And you know that is the job of log, to tell you this. So the mystery power would be what log? What would you type in? Log base 4 of 9. So provided your calculator lets you type in the base, you'll get the same answer. So you can see, of course, that this method is much quicker. There are the two ways to do this one. Okay, so can you write both methods down? Again, it depends on the question. So if it said exact, you should leave it like this. Actually, you could clean this up a little bit because you could change 9 into 3 squared. So you could change this into 2 log 4 3. And you could even simplify this a bit more.
2 squared?
Yeah, but you could change this into 2 over log 3 4. And 4 is 2 squared, so you can bring the 2 down. And then they cancel. And then this is 1 over log 3 2, which goes back to log 2 3. Yeah. Yeah, so this is as simple as I can make it. Yeah. Now, you had another rule you were showing me last time, weren't you, where there's what you could do if there was a power in the base. Yeah. Some people have seen a rule before where if you have a power in the base.
Yeah, it would be like 1 divided by 2 in the front.
Yeah. Well,
So it will be cancelled.
but yeah, basically, if you can write both of these as the same power, a 2 squared and a 3 squared, you can cancel squares. Yeah.
Or, for example, if you have just 2 squared.
Yeah, the 2 can come out. Yeah. So, like I said, the rules I did with you aren't all the rules because there's as many rules as you like, but they're the kind of key rules. Yeah. Okay. Next example now. Can I scroll down? Six power x minus 4 equals 9 power 3x plus 7. If you like, you can change 9 into 3 squared, but it's not really very helpful here. What we do is we put ln on both sides again. Yeah. Okay. And then we can take the power down. X minus 4 log 6 equals 3x plus 7 log 9. Expanding. log 6 times x minus 4 log 6 equals 3 log 9 x plus 7 log 9. Okie dokie?
No.
No?
Oh, okay.
I expanded. Log 6 times x, log 6 times 4. Log 9 times 3, log 9 times 7.
Just curious.
Okay, okay. Yeah, well, not two equations, just that you need to simplify. So, I'll bring the x terms to the left. Log 6 x minus 3 log 9 x equals 4 log 6 plus 7 log 9. What's in common on the left? X. So this becomes log 6 minus 3 log 9 x equals 4 log 6 plus 7 log 9. To finish, what is the last step? Divide. This guy goes underneath. Log 6 minus 3 log 9. So I have the exact answer here for x. X is that. Okay, well, you want to write this example down carefully. Again, it depends on the question. If they say, no, be careful, you said exact and you pointed to your calculator. That's not the exact answer. That's the exact answer. Yeah, this is a common mistake students make. They mix up the meaning of the word exact. So exact means this answer. And if they ask for the exact answer, then just leave it like this. But if they don't, you can give the decimal answer. There is some ability to simplify this. The 9 could be changed to 3 squared.
How would the minus become divided?
No, because you have a coefficient. The 4, the 7, and the 3.
Can we bring to the power?
Yeah, but then is it simplifying or is it getting uglier?
It's like making it smaller.
Take up less space. I don't know if that's the same meaning as simplify. I don't know. For me, not necessarily. For me, simplifying means trying to get it in a form where you could maybe not need your calculator or not need your calculator much. So if you were to bring the 4 up to power, which is easier? 4 multiply a number or 6 times 6 times 6 times 6? Do you get what I'm saying?
Okay.
I wouldn't count that as necessarily simplifying. To me, simplifying always means getting into a form that makes using the calculator minimum. That's what it would mean to me. Okay, do you have that one? Not yet. A few more examples to do. Yeah? Now, before I do the next example, I just want to remind you of a fact that I mentioned in the previous class, that e log x equals x, and log ex equals x. This is a useful thing to know for the next question. Basically, what I'm saying is an e with a log cancel, a log with an e cancels. Okay, let's have a look at the next example. if you have an exponential like this, believe it or not, it's always possible to write these in the form of a, e, b, x. You can always write them in this exponential form. And that's what I want to try and do with this question. So let's have a look at how we can do that. So the first thing I'll do is I'll split it like this. 2, 3x, 2, 4. Which I'll change into 2, 4, 2, 3x. Which I'll change into 16 times 2, 3x. So remember, we're trying to get it looking like this. So no surprise that perhaps this is going to end up being the a in the end. But we still have to do something about this guy, make it look more like this. So what I'll do next is I'll change this into 16. I'll just bring the 3x on the outside to make it look a little separated, more separated. Because what I'm going to do next is change the 2 into e log 2, 3x. 2 and e log 2 are the same because of what I said before the question began, this rule. If you don't believe me, you can check it on the calculator. E log 2 should give 2. So I've changed the 2 into e log 2. Now why might I do that? Well, I need to try and make an e appear somehow. So I'm getting very close to the answer. 16e. I won't multiply in the 3x. I'll just multiply in the 3 for the moment. So that's 3 times log 2. And okay, I'll multiply in the x as well, but just to make it more clearer, I'll put brackets like that. Can someone tell me what 3 log 2 is? Oh yeah, but what number is it?
So
3 log 2? Okay, 2.07. So 0.8. 0.8x. So what I'm claiming is that this and this are the same. Now, they won't be perfectly the same because you have to round. But, for example, if you put in a number like x is 1, this would be 2, or maybe 2 power 7. 2, 4, 8, 16, 32, which is 128. If you put 1 into this, you should get roughly 128. What do you get? Okay, not too bad.
Yeah, 128.0715.
So 3 significant figures, it'd be 128.
Yeah.
Yeah. So you can see that this and this are the same. Why? Well, I've done the algebra and I checked for a value of x.
Can you show one more time that shows that?
Oh, the e log x is equal to x and log ex is equal to x. Yeah.
the only thing that could be confusing is different names of logs.
So the
Symbols.
question is
Yeah.
to make in that form.
Yeah, to express this in this form. This form is much more convenient than this form. Because there's things you can do in this form that you can't. For example, for people who've studied calculus before, this is much easier to differentiate than this. This is easier to graph than this, because we know what the graph of this looks like. We did the graph of this one. Remember? Double positive, so it goes like this. Yeah, and this intersect point here is 16. Yeah? My point is that this is a much more convenient form to sketch, to differentiate, you know, to work with exponentials and logs. So this is why you might want to change the form. Yeah. This isn't a super common question in the exam either. The next example I'm going to do would be common enough. Can I scroll down? One sec, okay. Got it? Mm-hmm. Yeah. Right. Log base 9 x minus 2 minus log base 3 6x plus 1 equals minus 3. Yeah, what's the first problem, Ishpreet? Bases are different. It's a problem, isn't it?
Oh, everything right.
Huh?
Everything right. It will be like square equation. We will just put out 9.
We have to deal with the 9 first. But even before doing that, okay, before you begin this question, it's quite normal, and they might even ask you to do this in the exam, to say for what values of x is this problem defined, or in other words, what are the possible values of x. For example, yeah, well, yes, what were you saying for this one? Yeah, you must have x minus 2 to be positive. Remember, because we can't take the log of a negative. And 6x plus 1 must be positive. So this can be translated into saying x good, and this one?
X more than
1 over 6.
Nearly.
Minus
1 over 6.
Now we're not finished because of the and here. You want x to be more than 2 and this is important, and x is more than minus 1 over 6. So these two can be combined into one answer. X more than 2. That's the only way you can have both true, if x is more than 2.
Yep.
Yeah? Now some people are making faces like, this guy's crazy. What is he talking about?
Should be like
Yeah. If I said to you x must be more than 6 and more than 10, you can put them into one statement.
X more than 10.
X more than 10. Yeah? I'm just doing the same thing here.
x
Yeah.
more than 6. If like x more than 10 and x more than 6,
Yeah.
we should say that it's more than 6.
No, more than 10.
But we start from the 6, like it like
Correct, yeah, but
10 is like in the
I'm giving
range
you
of
I'm giving you
from
two
6 to
statements. I'm giving you two statements. The and. I want them to be both true. X more than 6 must be true, and x more than 10 must be true.
Should we write our conditions?
I
Every
recommend
time.
doing this. I recommend before you start to write this down, because it means that at the end, automatically you reject any answer that's not more than 2. Because this equation only makes sense if x is more than 2. It's only defined for more than 2. Okay? So when we get our answers at the end, we want to make sure that the answer is more than 2. Dasha, this is like what you said earlier about checking your answer. So I'm checking that my answer works by checking that it's more than 2. But I'll have to get my answer now. So as a couple of people were saying, the problem to begin this with is with the 9.
9.
We need to change it to what? 3. Yeah.
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 It
Yeah.
won't be the square equation.
Well, you have two choices. Some people, if they know the formula, can change it to 3 squared. What I'll do is use the rule 5, which is the change of base rule. Yeah? So I'll change this to log base 3.
X minus 2.
Yeah, and what goes under?
Log.
I already started with the
3, 9.
Yeah.
other version.
Huh?
I already started with 3 squared.
Yeah. Log 3 6x plus 1 equals minus 3. What is log 3 9?
2.
2. So this is a half log 3 x minus 2 minus log 3 6x plus 1 equals minus 3. Now, why can I not use rule 2?
It won't be nice.
Ah, no.
No,
It is true, but I still want to use it because of the half. So what can I do about that?
Multiply for half.
Where does it move to?
To the power.
To the power.
Yeah.
So you get
Minus
log 3
X minus 2.
x power, x minus 2 power a half.
Yeah.
What's the meaning of power a half?
Minus 2.
Yeah. No, square.
Yeah.
Square root. Now I can use rule 2. You see, so it's getting quite complicated now. So this is log 3 root x minus 2 over 6x plus 1 equals minus 3. See, it's getting a bit messy now.
Yeah.
But still solvable.
Yeah.
What should I do next?
Bring the log 3 to the
Yeah, well, how do I do that? That's it, yeah. Remember in the definition of log, you can say 3 power minus 3 equals root x minus 2 over 6x plus 1. So that's the same as saying 1 over 27 equals root x minus 2 over 6x plus 1. 3 minus 3 is 1 over 27, isn't it? 1 over 3 cubed. Yeah. Next, cross multiply. Oh no, I don't have to square this, do I? Okay. Next, I have to square both sides.
It will be 36 plus
36x squared plus 12x plus 1 equals x minus 2 times 27 squared. I only know what 25 squared is, 625, but I don't know what 27 squared is. 729
yeah, 17.
times 729. 36x squared plus 12x plus 1 minus 729x minus 1458 equals 0. Ugly. 36x squared
minus
717x minus 1459.
9.
Is there any chance 36 divides into both of these?
No.
5 7.
Hmm?
1
Oh, sorry. 5 7, isn't it? Sorry, yeah. Any chance 36 divides into these? I don't think so. No.
No, it's not.
Fine, we'll use the minus b formula. X is minus b plus or minus square root b squared minus 4ac all over 2a. So, x equals, we have two answers. Where are our two answers here, please? Two decimal answers. What is it? 21? Are you sure?
Yeah, 21.7.
21.7 or Minus 1.85.
This is
86 then.
This is 1.8.
What's that again? 21.8 is it? Yeah? Now, what's the problem with one of these answers?
Less than 2.
Yeah, so we have to reject this answer and then we only accept this answer. Because it's more than 2, yeah. Right, that is a very difficult one. Oh, if you can see it all. It's quite complicated. Write it down carefully, please. Three power minus 3 is 1 over 26.
Even
Which
if
one?
7 to 9 times negative 2 is a negative number, you bring it to the other side. So you
Oh,
bring it.
thank you. So this should have been, we'll just fix it here. On the right it was negative. I should have made it positive here.
Oh.
No, this is fine. It would have been much worse if the mistake was up here, right? So this is easily fixed. This would be positive 1, 4, 5, 9. So that just changes this part. Minus here, and then a 9 here. Okay.
So originally 1.58.
Yeah, but then plus 1.
Alright.
Yeah. I know I can add. I know how to add 1 to a number. I've got that skill down quite well. Right.
The answer is 17.6.
17.6.
Oh, okay. So both answers now work.
Yes.
17.6 or 2.3. Wonderful. Thank you for spotting that.
I decided to start from the second method, and now I can see the first one.
Yeah.
After so when the half flow
Yeah. Zoom in.
Yeah.
Here is so you want it like that, yes? More zoom in, more top.
yeah, that's fine. That's fine.
Here. Okay.
You could have multiplied 3 times.
You can multiply through by 2, and then what will happen is the root will be gone and this will be squared. So multiplying through by 2 is similar to when I squared later. In other words, you're making the quadratic sooner. That's what's happening. Okay, did you write that down? Yeah.
One second.
1 sec, yeah.
Such a pressure.
Faster, faster, quickly. Can I scroll down 1 line? We'll go 1 by 1.
Yeah.
Okay. Next line.
1 second.
Yeah, yeah.
How far scrolling down? So you can see the end, is it? Okay. I just want to go down one line.
Yeah.
Mhm.
This is the last example.
Right. So the ones I want you to try, which you can get a start on now for 10 minutes. Let's see. 1C, 2B, 3AB, 4A, 5A, 6A, B, C, D.
Did you finish the first method, like with introducing the new base?
Yeah? What do you mean? Anyways, get a start on those now, please. Mhm. Can I borrow a pen or pencil for something for a second? Thank you. Aziz? Again, yes. Is he only skipping my classes or was he missing the other classes?
All day.
All day?
Climatization, probably.
It took me 1 month.
Huh?
It took me 1 month probably climatization as well. He came from hot country.
Alright. David? There. Sabrina? Oh yeah, there she is, yeah, okay. Amy? Yeah. Ray? Yeah. Barack? Priscilla? Yeah, there you go. Patrick? Joshua? Umar? Diana? Mohammed Osman? Yeah. Okay. Thank you. Yes, one sec, let me just stop this recording.